Hello, everyone. I'm Dr. Wang. Here is the question. If x, y, and z are positive real numbers, xy plus yz plus zx equals 12. xyz equals 2 plus x plus y plus z. What are values of x, y, and z? How to solve this system of equations for the values of x, y, and z? We are going to use the important inequality, arithmetic mean and geometric mean inequality. From the first given equation, we have 12 equals x times y plus y times z plus z times x. The condition for using this inequality is all items must be positive from the given condition. X, Y, Z are positive. Therefore, XY, YZ, ZX are positive. We apply this inequality to the sum of these three terms. Then we have xy plus yz plus zx is bigger than or equal to 3 times the third root of xy times yz times zx, which is x squared times y squared times z squared. Therefore, we have 12 is bigger than or equal to 3 times the third root of x, y, z, then square. Let's define the third root of x, y, z as a, because x, y, and z are positive. Therefore, a is positive. This implies 12 is bigger than or equal to 3a squared. We just replace this part by a. Therefore, a squared is less than or equal to 4. Solve this inequality. We have a is less than or equal to 2. This is our first result. We use this inequality again for the second given condition. X, y, z equals 2 plus x plus y plus z. We only apply this inequality to the sum of the last three terms. Here again, x, y, z are positive. We are qualified to use this inequality. Then we have x, y, z is bigger than or equal to 2 plus 3 times the third root of x, y, z. By definition, we can replace the third root of x, y, z by a. Then we have a to the power of 3 equals the third root of x, y, z to the power of 3 equals x, y, z, which is bigger than or equal to 2 plus 3a. This is our second result. From this second result, we just move the left-hand side to the left, the right-hand side to the left-hand side. We use the grouping method to solve this inequality. We minus 2a squared, then plus 2a squared in the left-hand side. We group the first two terms and group the last three terms. We factor a squared out for the first two terms. We have a squared times a minus 2. Factor in the last three terms. We have a minus 2 times 2a plus 1. We continue to factor the left-hand side. We have a minus 2 out. Then times a squared plus 2a plus 1. The second part is a complete square. Then we have a minus 2 times a plus 1 squared is bigger than or equal to 0. This is our third result. By the result 1, we have a minus 2 times a plus 1 squared is less than or equal to 0. Why? Because a less than or equal to 2. Therefore, a minus 2 is less than or equal to 0. The second part is a plus 1 squared. This part is always bigger than or equal to 0. The product of the two terms equals this part times this part. A minus 2 is less than or equal to 0. A plus 1 squared is bigger than or equal to 0. Therefore, this product is less than or equal to 0. Combining results 3 and 4. Here is bigger than or equal to 0. Here is less than or equal to 0. Therefore, a minus 2 times a plus 1 squared must be equal to 0. This equal to 0. We have two solutions for a. A equals 2, a equals negative 1. Because a, by definition, is positive. A equals negative is impossible. We only have one solution. A equals 2. When a equals 2, all equalities, here should be equalities, hold. By definition, the third root of x, y, z equals a equals 2. Therefore, x plus y plus z equals 3 times the third root of x, y, z, which is 3 times 2 equals 6. By the condition of the inequality, here, from its result, because here the equal sign is true. Equal sign is true means x, y, z all are the same. X plus y plus z equals 6. Therefore, x equals y equals z equals 2. The only solution for this system of equations is x, y, z equals 2 times 2 times 2. That's all. Thanks for watching and see you next time.